Hello students, welcome back to my YouTube channel. In this video, I am going to discuss heating effect of electric current. You may be observed that when you switch on an iron box, it started to produce heat. You can observe the same phenomena. In fact, if the fan run more time, it started to produce heat. And in the case of bulb, along with the light, the bulb produces heat. And in the case of motor, TV, electrical bulb, and the case of mobile phone, all these devices are producing the heat. This is due to the heating effect of electric current. What is the heating effect of electric current? When a current flows through a conductor produces heat, this is known as the heating effect of electric current. Okay, this is the heating effect of electric current. When a current flows through a conductor, produces heat. Okay, what is the reason for this heat? I'll show you what is the reason for that. Okay, so I'm going to take a conductor and a battery. Okay, so this is a conductor. In that conductor, one end is connected to the positive terminal of the battery and the other end is connected to the negative terminal of the battery. Okay, so there is a key is there. If this key flows, the current started to flow through it. Okay, these are all conductor atoms. When the current flows, the electrons started to move from one end to other. So you see this, when the electron is moving through this conductor, it started to collide to the conductor atom. Due to this collision, some amount of energy of the electron is released in the form of heat. So when the current flows, that is the electron moving through the conductor makes some collision with the conductor atom, so that the heat is generated. Okay, this is the reason for the heat generated from a conductor. Okay, we can measure that heat. Okay, so for that I'm going to take a resistor. This is the resistor. It is connected in between X and Y, and the resistance of the resistor is R. The one end of the resistor is connected to the positive terminal and the other end is connected to the negative terminal through an ammeter. Okay, there is a voltmeter is connected parallel across the resistor to find out the potential difference. Okay, when this key closes, the current started to flow. Okay, so I am considering Q amount of charge. Q amount of charge flows from X to Y, flows from X to Y in T time. Okay, so due to this Q amount of charge is moving, the current is to be generated. Okay, then what is the potential difference across the X and Y? The potential difference between the two terminals is the amount of work done to bring a unique positive charge from one point to another. So the potential difference is equal to work done divided by charge. Here the potential difference we can measure from the voltmeter, that is giving us V is the potential difference across it. So that is equal to W divided by Q. So this W is equal to V into Q. So if a charge Q move from X to Y, there is a W amount of work is done. If this is purely resistive, entire work done is released as a heat. Okay, so this work done is converted in the form of heat. Okay, then so H is equal to VQ. Okay, then from the Ohm's law, we can say that V is equal to I into R. Okay, and this is equation number 1, this is equation number 2. From the general expression of current, we can say that I is equal to Q by T and Q is equal to IT. This is equation 3. Substitute this 3 and 2 in 1. Substitute this 3 and 2 in 1. So 1 becomes H is equal to, instead of V, IR. Okay, and instead of Q, we can write it as IT. So we will get H is equal to I square RT. This much amount of heat is released from this resistor. Okay, so this is the Joule's law of heating. Joule's law. Okay, the Joule's law states that the current flowing through a conductor produces current. Current flowing through a conductor produces heat. The heat is directly proportional to square of the current. Heat is directly proportional to square of the current, and the heat is directly proportional to the resistant, and the heat is directly proportional to the time for which the current flows. Okay. So this much amount of heat is generated from a resistor, that is I square RT. Okay, so all the devices involve conductor, so all the devices produces heat. In the devices like a motor, mixie, fan produces heat, and some amount of energy wasted in the form of heat. But other devices like electrical iron box, heater, oven, these are all the devices are working based on this principle, the heating effect of electric current. Okay, this is about the heating effect of electric current.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.